Hello Algebra 2, this video lesson continues with chapter 5.2 and the factoring of quadratic equations. But this time we're going to talk about situations where the coefficient on the x squared term is not 1. So the textbook offers you example 2, and I invite you to go and check that out and try to decide if their technique works for you. They give you this particular expression here as their example where, again, the coefficient on the x squared term is not 1, it's 3. And in order to factor it, there's a little bit more work to do than we talked about in the previous video lesson. But I'm going to show you a different technique than the textbooks. I'm going to show you a technique called cross them up and split the middle. I found that most students find this clearer and more successful. So this is the technique that I recommend. Different problem than the one the textbook gave you, but again, the coefficient's not 1, it's 8. If I have to factor this, the cross them up technique says I start by making myself an x, and at the top of this x, in this quadrant here, I'm going to put the number 8 times 9, or in other words 72. And at the bottom of the x, I'm going to put the middle term, the b term, 18. So in other words, always the top area here is the a term times the c term, 8 times 9 in this case. And the bottom is always the b term. Now the work is to find, much like we were before, factors of 72 that add up to make 18. So it's a lot like what we were doing back with the previous video lesson, but instead of just factoring the c term, we're factoring a times the c term. So find the factors of 72 that add up to make 18, and you'll find if you do that work, you'll eventually come up with 6 times 12 as the right answer. They multiply to make 72, and they add to make 18. Now we come to the split the middle part. We've crossed them up. Now splitting the middle means I keep the first term, the 8x squared term, and I keep the last term, the 9. But I split the middle. The middle term is this 18x, and I'm going to split it into two parts, 6x and 12x. Now, continuing with that splitting the middle, I'm going to draw a line between the left half and the right half. I'm going to factor each side. So on the left side, what can I factor out of 8x squared and also out of 6x? What do they have in common? Well, they have 2 and x in common. So I can factor both of those out. And what I would have left, well, what would happen if I factored 2x out of 8x squared? I'd have 4x left. And from this, I'd have 3 left. So what I have in the parens is 4x plus 3. Do the same on the right side. What do they have in common? Well, in this case, they only have the 3 in common. I factor that out, and what would I have left? I'd have 4x here, and I'd have 3 there, or 4x plus 3. This is good. This technique really only works, the split the middle technique is only going to work if what you have in parens on the left matches what you have in parens on the right. Now your answer is simply going to be pulling down the 2x plus 3, 2x plus 3 as one of your binomials, times 4x plus 3, your other binomial. That's the answer. Those are the factors of 8x squared plus 18x plus 9. Again, you're pulling down these two coefficients on the 4x plus 3 and making them into one of the binomials and keeping the 4x plus 3 as your other binomial. It makes sense because think about it this way. You've got 2x of these 4x plus 3 things and, or plus, you've got 3 of these 4x plus 3 things. So collectively, you've got 2x plus 3 of these 4x plus 3 things. I'll do another one. 18n squared plus 9n minus 14. It's going to come up with bigger numbers, unfortunately. The top is going to be 18 times negative 14, which is negative 252, and the bottom is going to be 9. So again, I've got to find factors of negative 252 that add up to make 9. Well, when you have a negative number, then it has to be a negative times a positive. But there are an awful lot of factors of 252, as I've listed off here. And I've just used that rainbow technique that I recommended to you before, where I start with 1 times the number itself, and then I see if 2 goes in, and it does, 3 goes in, 4 goes in. It feels like almost every number for a while there goes in to 252. But ultimately, when you make this list, you have to remind yourself, okay, well, when I multiply these, I have to have a negative number, but it adds to make a positive. The only way that can happen is if the negative signs are on the smaller of the two pairs in each case. So for example, if it were -1 times positive 252, that would be a positive number, 251. Similarly, if it were -2 times 126, that would be a positive 124. Whereas, just take this as an example, 14 and 18, if this were -18 times positive 14, then it would have come up with a negative addition, or -4 here, and I've got a positive. So I'm only going to have negative signs on the left. I'm just trying to give you a shortcut here. Okay, so now I've got to match these pairs up and find the pair that adds up to make 9, and that pair is 21 and -12. -12 here times 21 does make -252, and the two added together do make positive 9. Okay, now I just follow through on what I did on the last problem. I keep the left term, the 18n squared, and I keep the -14, but I split this middle term, the 9n, and I split it into 21n and -12n, as shown here. Then I divide left half from right half, and I try to figure out what can I factor out of the left half. Well, they have 3 in common and they have n in common, so I factor that out. The right half, they have 2 in common, so I factor that out. And actually they have -2 in common. So hopefully you worked it out and found that this is 3n minus 2 times 6n plus 7. If you had factored positive 2 out of these two, then what would have happened would be that you would have had -6n in here and -7. That would not have matched what you had in the parens over here. And remember, the exercise only works if the sets of parens, this binomial matches that binomial. So if they don't, then look again at how you did the work and see if there's some way that you can play with things a bit to get that to happen. Here is the answer. These are the factors of the question 43. One more that I'll work out, question 38 in your textbook. This goes a little faster. Hopefully you can see that at the top I would have 10 and the bottom -7, and factors of 10 that add up to make -7 are -5 and -2. So I keep the left and right terms and split the middle into -5x and -2x, draw a line between them, and factor, I don't have that line here but ought to, my apologies. Let's make that line so you see what I mean. And the left side now becomes 5x times x minus 1. But this time I only factored out, I'm going back and showing you the kind of example I had last time, I've only factored out positive 2. If you only factor out positive 2, then the right side becomes -x plus 1, which doesn't match what you had over here. So go back and see if there's a way that I can make this become x minus 1. And the way to do it is if I had factored out -2 from the right side. Once I do that, now I've got x minus 1 for this binomial and x minus 1 for that binomial, and that's what I'd wanted. My answer becomes 5x minus 2 times x minus 1. So with those three examples available to you, go ahead, hit the pause button, and when you come back, I'm going to show you the answers, but only the answers, to these three expressions that I want you to factor. Okay, I'm going to assume that you did that and you've gone ahead and factored all three of these expressions, and here are the answers to 19, 22, and 25. So hit the pause button if you need to study those answers. Oh, I'm sorry. I'd forgotten that the textbook factored these three problems in a different way than I'd wanted you to do, so they reported their answers in a different fashion. So this here is the answer I would have expected you to get for 19. It would have been fine if you'd written x plus 1 first, times 2x plus 2. Similarly, this is the answer I was expecting to see for 22. For 25, either of these two answers would have been fine, either 2x plus 2 times x minus 2, or x plus 1 times 2x minus 4. Both are perfectly fine answers. And again, the flipped order of either of these two is fine. Okay, but again, if you don't get these answers, don't hesitate to come into class and ask questions about them. Last thing I want to say, going back to question 38, and you'll remember we worked this out and we said these are the factors of this expression up here. Well, if I had instead asked you to solve this, if I'd said this was an equation, not an expression, and if I told you that this expression on the left is equal to 0, that would have meant the factors that you came up with would have been equal to 0. So in order to solve this, what you do is go through the process of factoring, and then the only way these two things could multiply to make 0 is if either 5x minus 2 is 0, or even and, x minus 1 is 0. So either it's x is 2/5, sorry about that, and or x is 1. That's the pair of answers, the set of answers I would expect to see if I'd asked you to solve this expression instead as an equation. Okay, so that's it for the lesson. Next time I see you in class, I'll look forward to any questions that you have about this, and see you then.